Hi boys and girls. For the last couple weeks we've been working on connecting our multiplication understanding to our division understanding. We've also been doing a lot of work with fact families, 2 multiplication and 2 division facts that all share the same numbers, which is how they're connected. Today our target is that we can solve for problems with missing numbers in different positions, but they have to be multiplication and division problems. However, before we can do that, we need to really understand the equal sign and even understand it in equations that are set up differently than you're used to. I'll show you what I mean. Okay, so let's start with the equation you are familiar with. 2 times 5 equals 10. So we know that that side equals 10. And 2 times 5, 2 groups of 5, that is also 10. So this equation is true. That's the way we're used to seeing it, where there is an operation on this side, add, subtract, multiply, or divide, and then the answer is over here. But the equal sign just means that both sides have to be balanced. So you could write this equation like this. 10 equals 2 times 5. Now I'm sure that looks backwards to a lot of you because it's not the way we're used to writing it in school. But it is still true because both sides are balanced. This side still equals 10. And this side, 2 groups of 5 or double the 5, that is still 10. True. So this idea that the equal sign means both sides have the same value, this is a huge idea in math. It's one of the most important things you need to take away from 3rd grade because you're going to use that idea in algebra in middle school, in calculus in high school, or even in classes beyond that if you decide to go that far. If both sides of an equation are equal, then the equation is true. If you end up with 7 equals 7, yep, that's true. But if you end up with 7 equals 12, that's a false equation. Both sides are not equal. So let's practice checking some equations together. We're going to see if they are true equations or false equations. You'll want your math journal so you can work along with me. Take a second and go grab that. All right, so I'm going to write an equation and I'm going to show you how to check if both sides are balanced and have the same value. Let's start with this. To figure out if this equation is true, I need to see what both sides calculate out to. I've got this side over here, and I've got this side over here. If the equation is true, both sides will have the same value. They'll be equivalent. To keep it organized, I'm going to just drop the equal sign straight down. That way, that side will always be over there, and that side will always be over here. That's going to get really important when you start getting more complicated equations as you go further in math. So let's build good habits now. Let's see, 3 times 4. We learned that one in our videos earlier, in last week and the week before, because we were counting by 4s. So 3 groups of 4. 4, 8, 12. And on this side, 4 times 3, 4 groups of 3. Well, we can skip count by 3s. 3, 6, 9, 12. It's also 12. So both sides are the same, it is balanced, and it is equivalent. This one is true. Some of you might have already known that just by looking at it at the start, because you know about the commutative property. That's a fancy way of saying you know your flip-flop facts, that with adding and multiplying, if you have two digits like this and you flip them over, you already know that that gives you the same answer. Very cool. So how about this one? This time, let's go and solve 2 times 6 equals 3 times 4. Remember to keep your two sides separate and keep the equal sign in the same spot so you stay organized. Well, we just did 3 times 4. We know that's 12. 2 times 6, you can solve that by doing 2 groups of 6, or by remembering that all the times 2 facts are just doubles. Double 6, that's also 12. This equation is also true. So, this time, let's make it a little more complicated. I'm going to start with 2 times 2 equals 10 divided by 2. This one's a little weirder because on this side we have multiplication and on this side we have division. But same way to start. Drop the equal sign down and let's calculate it out on either side and see if the answers are equivalent. So 2 times 2, that is 4. And 10 divided by 2. So imagine 10 of something in 2 equal groups. How many would be in each group? Yeah, 5. Oh, look at that. 4 does not equal 5. This is a false equation. 2 times 2 does not equal 10 divided by 2. Let's do one that's all division. How about 10 divided by 2 equals 15 divided by 3. So you're probably sensing a pattern here. First we drop down the equal sign to keep both sides separate, and then we solve each side. 10 divided by 2, that was 5. 15 divided by 3, well, let's think about taking 15 of something and making 3 equal groups. How many would be in each group? Yeah, 15 divided by 3 is 5 in each group. Well, look at that. 5 equals 5. That's true. This equation is true because both sides balance. They're equivalent. So, the last one that we're going to check for true or false, for this one, we're going to get a little bit crazy. And because it's going to get a little crazy, we're going to go back to addition. So it's get crazy in one way, but calm it down in another way. Take a look at this. 2 plus 4 equals 6 plus 9 equals 15. Whoa, there are 2 equal signs in this equation. Ah! But don't panic. Remember that both sides of the equal sign have to be balanced for it to be true. That'll be the case here with this equal sign, but also over here, both sides of that equal sign still have to balance. So to solve this one, I'm going to drop the equal signs down again to help us stay organized. And here on the end, we don't have to do any calculations. Just bring that 15 down. All right, let's look at the middle. 6 plus 9. What does 6 plus 9 equal? Yeah, that's also 15. Okay, so far so good. These two are the same. But let's check this last one. They all have to balance for this equation to be true. 2 plus 4. Uh-oh, that's only 6. This is not a true equation. These two are equivalent, but they are not equivalent to 6. And when it's all written together in one big long string of equal signs, every chunk has to be equivalent. They all have to be the same and balanced. So this one is false. Okay, by now you should be feeling all right about checking to see if equations are true or false. If you need more practice, join one of the Google meetings during the week or send me an email and I can help you then. For the next bit, we're going to get into that learning target about figuring out what missing numbers are. We are going to use the equal sign and what we know about it to help us do this. So now we're going to solve for some missing numbers using what we've learned about the equal sign and both sides needing to balance. For these problems, you're definitely going to want to write them in your journal and pause the video before I solve them so you can practice. Let's start with this one. 14 equals 2 times mystery number. What could you put in that box to make this equation true? All right, so I hope that in your journal you did something like this. You brought the equal sign down. We know that that side equals 14. Then for over here, you might have had a few different strategies. You might have thought about, what number can I double to make 14? Because 2 times 2's facts are doubles facts. You might have used your fact family knowledge. If 2 groups of something is 14, then you could split 14 into 2 equal groups and think about dividing 14 into 2 and how much would be left. But either way you did it, you would get 7 as your mystery number. 2 times 7 equals 14, and that side also equals 14. Nice job. I'm going to clear my board and write the next one, and you can write it in your journal. Okay. In your journal, write down 12 divided by 2 equals 2 times something. Remember to keep the 2 sides separate and solve the side where you have all the numbers first. That'll give you a clue to figure out that side. Take a minute and see what you make of it. Okay, you ready? First, I'm going to drop down the equal sign. And I'm going to do this side first because I can do 12 divided by 2. It's a lot harder to do 2 times box right now because I don't have any clues. Okay, 12 divided by 2, if I split 12 into 2 equal groups, I would get 6 in each group. Then over here, I know that 6 is going to equal 2 times something. Okay, what can I double to equal 6? I know 6 is 2 times 3. 3 is what can go in that mystery box to make both sides equal, to make it equivalent. All right, ready for the last one? I'll clear my board, and then you can write it down and solve it. Here we go. Last one to practice with me. 1 times mystery box equals 14 divided by 2. Pause the video and try to solve this one in your journal. Okay, here we go. So we need to calculate the side that has the numbers. So 14 divided by 2, talked about that one earlier, that equals 7. So 1 times something equals 7. And if you remember, times 1's facts are just the number stays the same. So, what times 1 equals 7? 7 times 1 equals 7. Our mystery number was 7. Okay, we're done practicing here. Let me show you the workbook pages for this week. We're going to do page 160, which should look pretty familiar with what I was just doing. There's a whole bunch of equations where you need to figure out if they're true or false. For those ones, if you need to use scratch paper to solve them with a little more space, that's okay. They didn't give you much room to work. The next part is like the other part of the video. They're giving you equations with mystery boxes in them, and you need to figure out what number you can put in those boxes to make them true. At the bottom, there's a story problem. Remember to write an equation that matches what's going on in the story, just like we practiced in the week before last with the cat story problems. If you have an equation that matches the stories, it helps you figure out your plan of attack. What do you need to do first? Is this a multiplying problem? Is it a dividing problem? Is it both? Maybe it's the kind with more than one step. Read it really carefully. We're also going to work on page 162. These are fact family triangles. To help you remember your multiplication and division fact families. Knowing your fact families can really help you when you're solving problems like these. Up in the top, they have the triangle that has the whole fact family. Here's the example: 2, a 5, and a 10. So you can write 2 times 5 equals 10, 5 times 2 equals 10, or you can start with the big number and divide. 10 divided by 2 is 5, 10 divided by 5 is 2. There should be 4 equations when you're done with each of these because there's 4 equations in each fact family. Down here, they've got most of the fact family triangle, but there are missing numbers. Here's the first one that they did for you. They had a 48 and an 8, but there was a missing number. And they wrote down how they thought about it. They wrote in a 6 because they knew that 6 times 8 is 48. You could think about it also as how many groups of 8 can you make out of 48? You might need to get some tools to figure that out, like I used my little gems last week to move them around. So, these are your workbook pages, 160 and 162. I look forward to seeing you in the next video.